So to recap what we just did, I asked for average word length for the Gettysburg Address. And I asked you to do this by choosing 5 words at random. And what I want you to think about is that the method that you chose was likely biased in some way. So I had, for example, a common way that people do this when I ask them to randomly pick is that they close their eyes or look away or something like that, and they point to a random word on the page. 2, that's 2 letters. And then they do that 5 times. Here's a problem with that, just to give an example. A problem with that is that is, if we're looking at, you can think of these words as area on the page. If you're pointing at random, longer words are going to take up more area on the page. And so that would be biased towards longer words, and you probably get an overestimate. So the way that we're going to do this in an actually random process here is I'm going to show you in the book and on the calculator that you can get this random process. So first of all, go to the next page. Here is the speech again, but organized by word count. And I want you in your book to flip to the tables where the normal distribution was. So the table's in the back of your book. And one of those tables should be table D. Table D, which is going to give you, it should say a table of random digits. So what we've done is numbered all the words. And we numbered them 1 through 268. And what we're going to do is we are going to basically assign each of those a 3-digit kind of code to assign to the word. And our goal here, our idea behind this method, is to give every word the same chance at being selected, the same opportunity to get selected. So what we're going to do is we're going to assign each word a digit, and we're going to use 3 digits. So we're going to go 001 to 268. And using table D, we are going to pick the first 5 of these 3-digit numbers we see. If it's a duplicate, we're going to skip it. If it's if it's outside the range, so it's not between 001 and 268, then we're going to skip it. So go to table D at the back of your book, and I'm going to start at row 101, and then I'm going to have you guys try it for different rows here to make sure that you can get it. We're going to go in groups of 3-digit numbers so that we don't So that we don't look at 1, okay, do we want 1, do we want 19, or do we want 192? Each digit is assigned to, each group of 3 digits is assigned. So to pick 1, we'd have to come across 001. To pick a 19, we'd have to come across 019. So we have 192. We have 239. We have 503, we're going to skip it. We have 405, we're going to skip it. 756, we're going to skip. 287, just outside, we're going to skip it. 139. Skip. Skip. Oh, I didn't get enough digits. I'll continue on the table itself. 531 we skipped. 425, 448, 285, 373, 676, 471, 509, 940, 001. So later down the list there's 001. And then we need one more. 927. 277 just outside. 544. 264. So these are the words we're going to pick. And the idea is that each number had an equal chance of being selected. And so 192, we look at what the 192nd word was down that list. It was 2. 239, that. 139, detract. We have 001, which is 4. 264, that is not. So this was 2 letters, this was 4 letters, this was 1, 2, 3, 4, 5, 6, 7 letters. 4, 3. So now we have our 5 words. We can take an average. Let's see. 15 and 5 is 20. And so we have 20 divided by 5. That's an average of 4. Do this in the calculator. To do this in the calculator, you would go to math, and I'm going to go over to this is considered a probability idea. So you're going to go over to probability, and what you're going to see is random int. So this will give me a random integer. So the nice part about random int is that it'll give you you won't have to worry about like having to skip numbers that aren't in the range, because you can determine the range. So I want a random integer, and it's going to say lower, upper, n. So what's the range of values you want to go? How many of them do you want? So my lower is 1, my first word. And then my upper is how many words there are, 268. So I want random numbers ranging from 1 to 268. I want 5 of them. So the idea is that we're using some sort of random number generator, random number table, something to make sure that everything has an equal chance of being selected. So there's my sample of 5 words from the calculator's random integer generator. there's the answer. 4.3881. I actually did go through and put all these in the list and get the average. It's 4.3881. So our sample won't get a perfect average, but it can give us an estimate without having to go through and tally up all the words. Or let's say we had a population of hundreds of millions of people, and we wanted to know, say, who they might want to vote for something. Well, we don't want to have to talk to all of those people, so like that takes time and money and resources that that we don't have, and so we randomly choose people to get a sample of. And so that process of taking samples and collecting data and doing experiments and potential sources of bias are what we're going to talk about in this chapter. That's what this chapter 4 is about. So let's do this. Back to the first page. Statistics is the science of collecting, analyzing, and drawing conclusions from data. All right. A few different terms here. Here's the important ones. The important ones are population. Population is the entire group that we're interested in making conclusions about. So in our Gettysburg Address, the population was the whole speech, every word in the speech. All 268 words in the speech. So if we went through and tallied up all the words in the speech and got that amount, then we'd be taking what's called a census. So if you're actually sampling the entire population, then you're doing a census. This doesn't happen very often. Like it happens, it happened this year in the United States. We took a census of everybody and gathered data. Counted up everybody. But usually we don't have the time or the resources or the means by which to collect data about every single thing. So, if we wanted to know about the makeup of grass, we wouldn't go get every blade of grass on Earth. We'd take some sample of the blades of grass and study them. So that's typically what we're doing, is taking a sample from the population. So that's the 5 words that we chose at random. That would be the sample. And so we can gather data, and when we are talking about the data from the population, that is taking a parameter. And this is where I've talked about notation for mean and standard deviation. And so here's the distinction. When you're talking about the entire population, doing the mean and standard deviation, that's going to be mu for mean and sigma for standard deviation. This is if you're talking about the mean of the entire population, the standard deviation of the entire population. And this is usually talking about a thing that we want to estimate. Usually we don't actually know what the mean of the whole population is. So a lot of the time, what we're going to use is our estimate of the mean and standard deviation from the sample. And that's what we're going to call a statistic. So that's where x bar and s sub x are going to come in. So that's why I told you when you did one variable stats, and we entered data into list 1 into the calculator, that was from a sample. And when we did one variable stats, I told you use s sub x and not sigma. That was why. because S sub x is the actual standard deviation of the sample. And the way you can remember these is that parameter goes with population, and statistic goes with sample. So the parameter is going to go with the entire population. The statistic is going to go with the sample. So the speech actually, let's do, I was saying the population was all 268 words. So the parameter in that case that we were trying to measure and estimate with our sample, we're going to use mu, the mean length of words in the speech. The sample is our 5 words that were chosen at random. And so the statistic we got off of that so my statistic ended up being 4 from my sample, is X bar. And in this case, my X bar was 4. And we're using that to get an estimate of what mu actually is. Mu actually turned out to be pretty close to that. So as we go forward, not so much in this chapter, but in some of the chapters going forward, I'm going to start to be nitpicky about which bit of notation you're using here. Because there's a difference between mu for mean and X bar for mean and what it's representing and standing for. Just like last chapter, there was a difference between y and y hat. Some of these are kind of jumbled and out of order, so you might have to find them. Convenience sampling is a bad method of sampling. So the convenience sampling would be something like if I had the words of the speech is like, well, I don't want to pick them at random. I just want to pick the first 5 words in the speech. No, don't do that. That's probably going to be biased in some way, and how it is will depend on the example. Voluntary response, participants opt into responding. This is also bad. It's biased towards strong opinions. We'll talk about that more when we talk in detail about bias, probably on Thursday. Here's what you want to write down. Simple random sample. This is abbreviated SRS. That was when we took the table of random digits or the random int on the calculator and gave us a sample at random of 5. So that's on the page that's headed with sampling methods. Simple random sample, abbreviated SRS. And the idea of the random sample is that every individual has an equal chance of being selected. That's what we want to create. Every individual having an equal chance of getting selected. So I've talked about bias. I don't want us to confuse that with variability. So I want to talk very quickly and say we have two different ideas of what these look like. These are back near the start of your notes. So bias is when there's actually something with the method of our sample that's causing the results to move a certain way. So maybe in some way, with the way that we chose to do our sample, we're like undercounting or overcounting a certain group of people. Or I talked about how pointing at a word at random will overcount the long words because they're more likely to be chosen if I'm just pointing at the paper. So that would be a biased method. But don't confuse that with the idea of variability. Variability says that the range of values when we take repeated sampling can vary. This is natural in sampling. When I asked each of you to pick a different line on the random table, you each got a different average than I got when I picked line 101. And out of the calculator, I got a different method. So just based purely on luck and chance of the method of the group of 5 words that I chose, I got a different answer. That's natural to happen when we take samples. But if there's something with our method that is causing the results to tend to overestimate or underestimate, that's when we're looking at bias. And we'll talk more about that later this week.